So, hello everyone. Today we are doing PR number 30886. This involves adding support to populate PSBT input utxos via RPC. So, to get an idea of why we are using, why we are adding this PR or why we have this PR, uh, we we have to look into a bit about PSBTs. So, what are PSBTs? PSBTs stand for partially signed Bitcoin transactions. So these were introduced in Bitcoin version 17 in I guess around 2017 or 18. Uh, so a lot of wallets at the time were using uh, multi-sig approaches, and all of them had their own custom implementation. So to avoid that, we had BIP 174. This introduced a standard to involve partially signed Bitcoin transactions, and this involved this big of a format of adding uh, global types as well as inputs and outputs. So you can have a look at them here. So to get an idea behind why we would need that, we would like to know about this. So we can have an example. So let's say that we have two persons, Alice and Bob, and we would like both of them to be like both of them are paying for some service, let's say, and we would like both of them to be using their own UTXO. So let's say UTXO UTXO 1 is of Alice and UTXO 2 is of Bob. So we want both of these UTXOs to be in a transaction, and this is to be sent to, let's say, some X, and for some reason Alice and Bob are not simultaneously available, and let's say Bob is unavailable at the moment. So what Alice can do is she can create a transaction, a PSBT, with her own input UTXO and her own signature. So this is not finalized yet. This has a lot of room for addition. So this PSBT format with the additions to it are sent to Bob, and whenever Bob is available, he will add his own inputs and add his own signature, and then will broadcast the transaction. So this is the idea behind having partially signed Bitcoin transactions, and these involve a great number of advantages. So first of all is this uh, example which I demonstrated. So even if I don't have the wallets right now for UTXO 1 and 2 simultaneously, like at the moment, I can even then I can create a transactions that will pay for some service X that both of Alice and Bob like had, and this is like one of the advantages. Some other advantages are listed here. So yeah, one of them is interoperability. Before this, there were a lot of issues with the design of various Bitcoin wallets and these softwares, and um, also then they had their own PSBT implementations. This made it difficult for them to interoperate with each other. So PSBT then gave us a standard that all of these wallets, whatever the software, whatever the implementation they have to adhere to this particular format of PSBTs to have these accepted in the Bitcoin blockchain. So this made it easier for the wallet to like have a single implementation, and they were able to operate with each other efficiently. Also, we have another advantage with offline signing. So we with the PSBT format, it gives us a lot of information about the input count, output count, which can be modified after that. There are some roles that are defined here, uh, which can be seen here. So these are the roles. So first of all, PSBT is created by a person on creator, and it is an unsigned transaction, and it's placed in a PSBT standard, and it has empty inputs and output fields. Now there are a lot of updaters, so they update the PSBT inputs with utxos and other things that are needed, like redeem scripts, witness scripts, and the PIP32 derivation parts. Now there are also the signers that will sign those utxos for us, and we are given a signer algorithm here, which is not part of this session, but like you can have a look into this after the session. Then there is the combiner. The combiner will add multiple PSBTs together and then finalize it to the input finalizer. Then finalizes the inputs of the PSBT and creates a finalized script sig with OXO7 and OXO8. OXO7 finalized script sig and OXO8 finalized script witness. So these specifies that the transaction that we have is a that the transaction that we had was a PSBT transaction with multiple signers, and then there is a trans transaction extractor that accepts a PSBT into the blockchain. So this is how a PSBT lifecycle goes. This metadata that I showed you before like provides a lot of information for the cold storage devices, the hardware wallets that we have. So we can do a signing with this cold storage with more security, because we have a lot of information about the previous inputs and the other things, the signatures, etc. that we would need. We can then create a transaction and then broadcast it. Also, this is we have multi signature signing with it. The multi signature signing, the first point that I raised, that we can have a lot of parties that have their own UTXOs, and then they can sign their UTXOs to have in a single transaction, even if they are not available at the moment. And then there are multi-party transactions. So if we want to like have a single transaction, uh, with a lot of things combined, then PSBT helps. It is used in CoinJoin, CoinSwap, and PageJoin protocols. Uh, all of them are privacy preserving, that you can look into. And these are like some of the advantages that PSBTs have. So going back to the PR, the issue was that uh, a user would want to like sign the child transaction without having the parent transaction in the mempool. So uh, we can't do this in PSBT RPCs as of right now, but we can like do it in the raw transaction RPCs that we can interact with. So what we do is that we first sign the transaction and then give the information about the parent transaction if we in the RPC itself. So even if the RPC is not available, uh, even if the transaction is not available in the mempool, we can sign the child transaction after giving the parent transactions info. Keeping in mind that the parent transaction should be a valid transaction, and we must be sure that at some point of time it will come into the mempool and will be accepted. And this is the functionality that we would like to have with the PSBT RPCs. So this PR then adds this functionality into it. How it is adding this is like it is adding an optional argument for utxo update PSBT. This is doing nothing but just adding a placeholder for previous transactions, which which would be the parent transactions of the child transactions that we would be having. And then it is injected into like this is injected in utxo form in these serialized transactions, and these pre-private inputs then can be found in the PSBTs, and the input of the child PSBT then can be populated with these previous transactions. So this is the functionality we would like to have. So looking into the file changes, uh,
So,
we have
Prabodh, what would be the use case for us to have the child transaction signed? Like we want the child transaction to be signed, whereas we're not even broadcasting the parent transaction. What would be the use case where you would want the child transaction to be signed when you are not even broadcasting the parent transaction?
yeah. So like you can take an example of like let's say we can take the case of Alice and Bob, and we take the example of like this service X. So service X would like to create a like child transaction of the PSBT transaction that Alice and Bob did. But since Alice created a PSBT and we are sure of that it would be a valid PSBT, and like we will have it in some point of time. And but since Bob is not available and is not like available to sign, we can't have it instantly. And so this creates a problem for like service X, because we are sure of getting a payment, but we can't use it because of unavailability of one of the signers. So like there is a huge trust in the parent transaction that it will be included in at some point of time in the mempool, and then uh, we can then use the child transaction like to do other stuff. So like it just uh, as like we have an urgency to use the child transaction, but we don't have the parent transaction in the mempool yet. Like this is one of the use cases that we would that fulfills
Mm,
the
right.
criteria
So
of
like up
yeah.
till now we had the provision of creating child transactions of unconfirmed transactions, right? So if somebody broadcasted a transaction, even if that transaction is not confirmed in the blockchain, you could still create a child transaction for it because you trusted that that transaction will get confirmed at some point in time. Now what this does is that even if the transaction is not broadcasted, just the fact that it is created or it is partially created and you trust the creator, it gives you the provision to add a child to that transaction.
Yeah, correct. So like we don't have to wait for them to like have the transaction in the mempool yet to like have a like to then even create a transaction. We can like recreate the transaction, have it in the mempool, and then when the parent transaction gets uh, like included in the mempool, then automatically the child transaction is like can be validated.
Okay, right. So, two questions. Firstly, Alice has added her input and her output. Okay, we are waiting for Bob's input and Bob's output. So the child
Yeah.
transaction can only spend from Alice's output, right? Because we don't know what Bob's output is up till now.
No. We can like we have like we will make sure that we will know what will be the total in like total amount of BTC that we will be having. We are just to make sure that we use both of these. Yeah, like we have the metadata of what the transaction final transaction would have an idea if it does not get updated before like after that.
So is
Like
it
if
only that
the
Bob's signature is only Bob's signature is remaining?
yeah it like it's just that Bob has to like add his input and also the signature to it. We
Right.
know that he will be using that input and we'll be getting this much amount of
Okay.
Bitcoin.
Okay. Okay. Cool. Got it. And the second question, or the related question, is that uh, is this child transaction eligible to enter the mempool even though its parent is not in the mempool, or you can just create a transaction and not broadcast it till the parent is ready?
I guess if the like if we don't have the parent transaction signed yet, we can't like enter it into the mempool because even in the child transaction we will have to add a prev-out transaction ID, and without all the inputs and the signature we would not be having a final transaction ID. So like we can't have a valid prev-out till that period of time. So
Right.
we'll have
Cool.
to like hold on to it.
Cool. Yeah. Let's proceed.
Yeah, like this is one of the disadvantages of it, that like, we won't be able to use it until and unless we have the final transaction ID of the parent in the mempool. So yeah, so there is another way of like thinking about this. So normally how the Bitcoin transaction like how it goes is like we have some inputs and we say we use X amount, we receive Y amount back in change, and this information is like included in transaction one, and the output of this is then the input of some other transaction two, uh, which will be having some x1 and y1, uh, like exchange of money, like exchange of Bitcoin in it. So this is normally how the workflows goes, but we can have an intent centric chart transaction also. So let's just say that we have a parent transaction and this is the child transaction. Uh, we know that we would like to use x1 amount of Bitcoin and receive y1 amount of Bitcoin back. This is what we want to have, and we would like to add parent transactions in such a way so that this is satisfied. So this is kind of a reverse thinking of this, where from the available input we create an optimistic or feasible output, child transaction outputs, and then use it in the child transaction. Whereas here we are specifying that we would like x1 Bitcoin to like be in the output of this child transaction, and y1 Bitcoin to be given back as change, and then we will have to gather parent transactions so that this idea or this uh, constraint is fulfilled by the by the parent transactions. So this is one of the way of thinking this method uh, thinking one of by one of the ways how we would like to have these child transactions signed before even the parent transaction enters into the mempool. Now we will look into the PR. So we have a
Can
in
you
the
zoom a little, please?
client.cpp we have addition. Is it good?
A little more, if possible. Yeah. Thanks.
Okay. So we have this utxo PSBT RPC added, and a descriptor process PSBT has also been added. Yeah, so in the process PSBT RPC, we are adding another variable, uh, optional variable. We will have a vector of parent transactions that we would like to that we would like a child transaction to have. So this is one of the additions. Then to ensure that in these parent transactions we don't have any repetitions, we do a check of unique transaction IDs. Uh, if the previous transactions, if there are transactions in the previous transactions vector, we iterate over each of them and check if there is another one of them here in this vector. So if there is one, it throws an error that there is a duplicate transaction ID, uh, and goes and the execution is halted. Whereas if it is not there and it's a unique transaction, then it is added back. Now in the map that we have created, we look for the transaction inputs, the outputs hash. So basically the transaction ID, and we set it the transaction equal to this transaction ID. So we check for the mapping, that if the mapping is correct. So in the PSBTs, we have kind of a mapping between inputs and outputs, so that when we are applying a signature over it, we can have a valid signature. We can't have it in such a way that there is input 1 and input 2, and let's just say input 1 has outputs 1, 2, 3, and input 2 has outputs 4 and 5. It is not like stored in such in a random way, like 1, 4, 2, and then 5 and 3. It will be systematically stored with its corresponding outputs. So 1, if there is an input 1, we will have 1, 2, 3 outputs there. And if there is input 2, we will have corresponding 4 and 5 outputs here. So we will have the information that this input corresponds to these number of outputs, and then we'll check in this order. So like maintain that the signatures that we have don't like jumble up and like sign the wrong inputs. So we are implementing that here. We are checking if the previous the trevout.n is in the right index of it. Uh, we can have an error that it has too few outputs, or like it may have too many outputs. And then we have a sanity check to look into the transaction index, and then find the transaction uh, in the mempool. So all of these provided transactions, the child transaction is dependent upon these previous transactions. We have like added these RPC helpers for previous transaction to add previous transaction, and uh, a serialized output for these transactions that we are adding. So this is the implementation of utxo update PSBT. We create a vector of previous transactions we check for if the so like the first two params are the RPC that we request, and then after the second uh, argument, we check for if we have this update utxo update PSBT RPC that we are using, and if it is not equal to null, we are using it. Then we get an array of row transactions. We reserve the we update the size of the previous transactions that we created here to the size of the row transactions that we received, and we iterate over all these raw transaction and like deserialize all of the transaction to decode the transaction and see if they are valid transactions, and if they are, we like store it in the previous transactions back and make a transaction reference with the std move mutex std move mutex in the previous transactions, which is then added to the PSBT later on. And yeah, here it is adding it to the PSBT. We are then also adding these RPCs in the raw transaction.cpp. There is this is the same implementation that we saw above, and then again it is being added to the PSBT. So there is a functional test that has been created to check for this, a test to check uh, that the PSBT can have user provided utxo field inside. So we create a PSBT parent with the wallet create funded PSBT. We get a new address PSBT, and we then process this PSBT parent transaction of the PSBT. We then decode the raw transaction. Then we like take the transaction ID of the parent transaction from the decoded info and set its first just set the first output to spend, and then we create a child PSBT. Yeah, then we create a child PSBT with the transaction ID of the parent transaction, and we out of the parent transaction we get a new address, and we have the parent transaction info with v out and 0 and a value. So this is the out this is the input that we have. So this then
So that first
uh,
output of the parent transaction is the input of the child transaction, right? That v out zero below that. That v out zero, it differences the first below that. Yeah, no, below that. When we're creating the child, yeah,
yeah, this one.
this
Yeah,
is the output of the parent transaction. That first output of the parent transaction is the input of the child transaction.
as the output, and there's no change back.
Okay, all right. Because it's a
So
sample transaction for the sake of testing, for the sake of simplicity, we just have one input and one output and no change.
yeah, exactly. We
All right.
just have a single output, and this is being set as the input. Uh, the reason behind we having this decimal is because we have the value in sets, but it is displayed in decimal. So this is to account for that. Then it checks for uh, time this transaction. Like we process it with this. We process the child transaction uh, with a wallet, and we get a response. Uh, we assert that the response is not complete. That is because we are not the one finalizing it. The role of the we are just updating the transaction as of now, and then we add the processed parent transaction into it. We update. We are now filling the role of updater. We update the transaction with the parent transaction, and then process on it again, and then we assert that the response it has is complete, and the processing of the PSBT is complete. And we are now checking that the response of the previous descriptor, the non-PSBT descriptor that we are using, is also the same as of this, that the PR had, but this way of adding the parent transaction that the PR has like introduces. So we are using this descriptor process PSBT and asserting that the response of this is also complete. And we have a test to check that multiple inputs are also okay, even if unrelated transactions are included. So what we are doing is we have a lot of transactions in the previous transactions, and we are processing it. We are creating a new raw transaction with all of these unrelated present parent transactions. So we can have all of them as independent or dependent. There is no restriction on that. And then we then update the UTXO with this UTXO update PSBT PC that has been added in the PR, and then we process on it. So UTXO update PSBT takes into account the child PSBT and previous transactions, uh, the previous transactions raw transaction, and then we are like processing it again, and we assert that the response is complete. So if only irrelevant previous transactions are included, it's a no op. So suppose that in the previous transactions, someone has included transactions that are not going to be used in the PSBT, the child PSBT, then we have to discard the entire previous transactions, because once we have added the transactions in the PSBT, all the transactions have to be related to the child transaction. Otherwise, like, we won't have a proper mapping from the inputs to outputs and this and this signatures, and that would create problems. So we check for that case. We create raw transaction again. We update the UTXO again. We process on it, and then we check that the response is that there is no completion. Also, like, if there is a collision, like there is repeated transactions included, it is also rejected. And this is the test for it. Uh, so this is so the last case uh, that we would like to check is that if the transaction IDs match, but the amount of outputs that we were expecting does not match, it has to reject the transaction. So we are checking for it again. We create a PSBT with transaction ID of the parent transaction ID. We are using the single transaction ID here for the sake of testing. We have a vout. Uh, we have the value as this, and we get a new address parent transaction info. We take off the vout of the present parent transaction. Zero, since there is a single output, zero is the vout, and the value, and we have the value from the parent transaction decimals. We process the transaction parent transaction and assert the error that this has too few outputs for the PSBT input, or the value does not match what we were expecting. So yeah, this is about the PR. We can like
Yeah, I feel the test cases are very comprehensive. They test for TXID collisions. They test whether the amount is adequate and also quite a lot of different cases. I think four different cases or four different scenarios are being tested, right?
yeah. So these are like almost all the scenarios that are trivial. Otherwise, like we can do a first test also. Like there can be scenarios and some edge cases where it can fail, but it does not come to you trivially. It can only be found in like first testing. So like
Right.
a first test being included here is also a huge plus, but like it is fine with these many tests also for now, since we are like only adding in for the implementation.
Right, great.
Yeah. So like then we can look into the questions. Okay, so the first question is, what are PSBTs? How and why are they important? So like if anybody would like to answer that.
Hey, would anybody like to answer this question? You get $8. $8? How many dollars per vote?
We have $10 worth of SAT per question as a bounty.
Yeah. So who wants to win $30? 30 quick dollars? Anyone? What's the question? Maybe we can read the question.
Yeah, so the question is, what are PSBTs and how and why are they important?
Yeah, so can we only answer any one of the like first question only if we don't know the other two answer?
Yeah, feel free.
Yeah, yeah. So I think you comprehensively explain the use cases of PSBT in the starting of the session. So what I understood from your explanation is that PSBT is the full form is like partially signed Bitcoin transaction. So it has the different use cases were mentioned. The first one was the multi-sig one where two different or two or more than two different spender can be there for a single transaction, and they can all do signing of the transaction independently. And once they independently all the participant sign complete the signature, then only they can do the transaction of that particular transaction. The second one was related with the cold storage. So anyone, since the signing part can be the creating of the transaction, and applying the signature to it can be done independently. We can create a transaction on an online wallet, but still we can use an cold storage to do the signature for the transaction that we have created. So this way, it gives the flexibility to many users to use a cold storage for creating the transaction itself. So yeah, these are the two use cases that I am able to recall. But yeah.
Yeah, nice answer. So this sums up why we would why PSBTs are important. The other two we have privacy preserving protocols like PayJoin, CoinJoin, and CoinSwap uh, that like use these PSBT format to their advantage, and like CoinSwap is like also projecting some of Bitcoin. So if you would like to contribute to it, feel free. Like contributions are always welcome in these projects, and you can learn a lot by contributing to these projects too. Okay, so now coming back to the questions. Uh, what is the need for signing child transactions when we don't have a parent transaction in the mempool? So anybody would like to answer?
Anyone in your own words, like I think we covered this in the session. So whatever you heard in the session itself, maybe you can mention. We talked about how we would need a child transaction because we trust the creator of the parent transaction that they will create the parent transaction. So even before the parent transaction is completed, we want for some reason the child transaction. So would anybody like to summarize that in their own words?
Yeah, like anybody can answer. There are no right or wrong answers. Anybody, like everybody has their own views of uh, what is
I
being taught, like and how they
I
got
will
this.
not answer because you guys owe me at least $200.
Okay, okay,
Make the previous payment first, then I'll answer more questions.
for sure, for sure.
Okay, I think you can
Like,
answer. See, the role he's not getting paid.
like I'm getting robbed here, but I guess
Okay, no worries. The status for and Raj, I think Raj is going to pay, so you can start DMing Raj for your $10 rule. Just when this session gets recorded and goes on YouTube, then you'll have a proof. Just send him a link asking for $10. Yeah, very pro, but you can summarize the answer.
okay. So for this, why do we need? Like, I explained why I would need that. We would since one of the drawbacks of the Bitcoin blockchain is that transactions are slow. So we would not like to wait for the parent transaction to come through in the mempool to start creating a child transaction. So what we can do is that we can create a child transaction with some intents that with the knowledge that what is the amount of transactions that what is the amount of Bitcoin that we are going to have in the output that will be given to us in the input, and what we would like to do with that amount of Bitcoin. So partially create the we can create a child transaction by having a PSBT parent transaction in the input. So whenever the mempool, so whenever the parent transaction goes through, we can instantly send our child transaction and we don't waste any time. So like this is the big implementation advantage that we have with the that we have when signing the child transaction, and we don't have a parent transaction. So the last question is, what is the technical difficulty when creating intent-centric child transactions? So I'll explain this one. So intent-centric child transaction is the second way of thinking for the child transactions being signed without the parent transactions. We would like the child transactions to have some specific inputs and output, and we would like our parent transactions to give us the outputs in such a way that these child transactions are fulfilled. So if anybody would like to answer that, like it's a one-liner answer. I gave the answer to it in the session as well. If anyone recalls that.
Anyone, feel free to go ahead, guys. Jatin, $10. No, he
Yeah,
doesn't want. But maybe you can summarize, Prabodh.
yeah, yeah. I'm shocked that no one wants free money. So let me answer that. So implementation details that like that is the major difficulty is that in the transactions we would already like to have the prev output transaction ID. So the transaction ID of the parent transactions, which is a huge drawback since when since we the P in the PSBTs we have not finalized the transaction, so we don't know what the transaction ID of uh, parent transaction would be, so we can't include it in the chat transaction as of yet. So like this is the drawback that is currently like plaguing the
Right.
implementation of the intent-centric child transactions.
So up till now, when we were creating child transactions, we knew exactly what the parent transaction would look like, what the output will be, what the input will be, what the TXID will be, what the V out will be. We had all the information to craft the child transactions. But here we don't have all the information, and even if we have, it's not certain. It's not certain because the parent transaction is not yet finalized. So that is an impediment or a hurdle, right? They're creating a child transaction without having a finalized parent transaction.
Yeah, absolutely.
Right. Somebody's typing something in the chat. Coding piece typing in the chat. She has a question. If the parent is a PSBT, then the child will be one too.
That's a nice question. Uh, I'm not sure like if we can think of like if you're like the child transaction to not be a PSBT, uh, we would uh, want to know what the transaction ID of the parent would be. So that is at the moment kind of impossible and a technical difficulty. So yeah, since the parent transaction is not finalized, we would not like our child to be finalized also. So the child transaction will have to be a PSBT2. Otherwise, like we'll have to once the parent transaction comes, we'll have to again change the child transaction, which will not be beneficial. And we are like back to square one.
And that is a very good question.
Yeah, that's a really good question.
Exactly. It did not strike me at all, but yes, that's a very good question.
Yeah, like we can add this in the
For
in
hundred
the
dollars.
issue and yeah, another $10
Right.
question. Okay, then this wraps up the session for today. So thank you everyone for joining.